this is a real dream becoming true. So Dave, I want to thank you for doing that. I will present a little bit, as Dave told, an introduction about NuttX, but I will start speaking about the industrial IoT. So it's a very small introduction to industrial IoT or Industry 4.0, and then I will talk how NuttX can be used to create industrial IoT applications. This is the agenda: introduction to industrial IoT, introduction to NuttX, comparing Linux with NuttX, why to use NuttX for industrial application, and how we can get involved. I removed this part, in fact, because I suppose almost everybody here is already involved in some way with NuttX, but basically the idea was to present about the Google groups and the YouTube and so on. Can you still hear me?
No, we lost it.
Yeah.
Stopped working.
Maybe the battery. Yeah.
We have space. Keep talking.
Okay. So the Industry 4.0 means this is the fourth industrial revolution. The first one was the original industrial revolution that happened in the British. Basically, it was the invention of the steam. Okay. The steam power, and you can replace, for example, horse by vapor motors to do something. Okay, and it revolutionized the production of some clothes and something like that at that time. The second industrial revolution was the mass production, the assembly pipeline. It was basically, when you talk about it, we think about Henry Ford with the Ford motors, producing many Ford Model T cars around 1908. And then we have the third, when we start to use computers and CNC, automation, and something like that. This was the third industrial revolution. And now we are starting the fourth industrial revolution, where you have cyber-physical system communicate between all machines. Basically, these are the idea of the Industry 4.0. We have decentralized control. It is driven by IoT, Internet of Things. Your manufacturing plant will become smart. It can sense the environment and can adapt to the environment. And because it is connected to the internet, to get information from your supplier and from other companies, it's also a vector of attack. So the cyber attack is a real concern when you talk about industrial Internet of Things. And these are the basic principles. As I told, all the devices need to interoperate. So we have all devices communicate. The information transparency, it need to exchange information in an easy way between all the devices. It needs to be service-orientated. So if you have some product where your customer decide, oh, I want this product with this color and something like that, some different configuration, it automatically needs to be orientated to this using the service orientation. It needs to be decentralized, as I told in the previous configuration, in the previous slide, and it needs to be visualization. They call it virtual twin. So you have your plant, your factory, and you need to have a virtual copy of this infrastructure where you can see how the things are working, how the devices are communicating between them, and it needs to have modularity. It means if today you are producing such kind of product where you have a configuration, but tomorrow this product is not necessary, you can reorganize your factory to create other product. Today, almost all the factories are static. You create the pipeline for a product, and if you create other product, you need to change everything. So the idea is to have modularity. These are some of the main components. Cybersecurity, augmented reality, big data, autonomous robots, additive manufacturing, simulation, system integration, cloud computing, and Internet of Things. All these components are necessary to Industry 4.0. Here is an example for the Fiat Chrysler company. This is a factory in Brazil. This is the first FCA factory to use the concept of the Industry 4.0. I'm not sure, but I think it was developed by Siemens and Microsoft, and they have some agreement to make it happen. It has 700 robots. They can mount every piece of the car. Everything is mounted without manual interaction. Only something are doing by human. For example, pass the harness in the car, because it's a little bit difficult to robot to have the dexterity to put some harness around all the vehicle. But maybe in the future, even this part could be done by robots. It's already integrated with the supplier, and as I told, it follows the concept of the Industry 4.0, and all the pieces can be traceable. So you have all information about all the pieces of the car. I have a picture here. This is the assembly line with some robots. Okay? So, what you need from RTOS to support industrial IoT? I list some things are important to have. IPv4, IPv6, 6LoWPAN, MQTT, and other network protocol and interface. Connectivity, Wi-Fi, Bluetooth, RFID, NFC, and many others. Okay, but Internet, but mainly these one are the most important. For industrial interface, we need to have 485, CAN bus, EtherCAT, and many others. Real-time support for process and to robot control. About the language, you need to support C, C++, Java, Python, Lua, maybe .NET, and other important programming language to be used. For artificial intelligence library, for example, libdeep, mplib, tort, TensorFlow, and many others. For image recognition, it should support OpenCV, libccv, and others. OpenCV is a little bit bigger to use in NuttX. Depends on your board, but normally it's big. But the libccv is a Chinese project, and it's for small hardware. You don't need to have many megabytes of the memory. Okay. For security, you need to support crypto AES, DTLS, TLS, and other crypto algorithms. These are some examples of product in the market running Linux. Running NuttX. Just a comment before starting with NuttX almost 10 years ago. I start 20 years ago with Linux, so it's still some memories, old memories of Linux in the past, and NuttX is very similar to Linux in many ways. So this one is the Halcyon Think C1. I think Halcyon guys didn't came for this conference, but should be nice to have them here. We have the Sony audio recorders. Masayuki working in this project from scratch. He's the guy who selected NuttX to be used on this product. So thank you, Masayuki, for doing that. And also we have here the Motorola Snap cover. It's this smartphone, and you can use like a projector, or you can use JBL audio system or analog camera. They adapt to many other modular devices. This one is the PX4. We have the David Sidran working in here in this device. He's the expert guy working in the PX4. This one is a thermal printer used in Brazil. It's a Daruma company. They developed it about 3 years ago. I think it was the first thermal printer using NuttX in the market. So, what is NuttX? It was created by Mr. Gregory Nutt. We have the pleasure to see him here in person. It was publicly released in February 2007. It supports microcontroller and microprocessor from 8 to 32 bits. In fact, yesterday we are talking about the Chinese guy who are porting it to AMD 64 to Intel 64 bits, but they released the initial port in the GitHub, and then they remove it from there. And I don't know, I hope someday he finish and publish the source code. It was released under the BSD license, so you can use it to create proprietary applications, proprietary products, and you can use your proprietary application with it without worrying about releasing your application. For example, if you use GPL, you cannot do that. So, what is NuttX? It's a RTOS with a small footprint. It is very configurable, customized. It means you can adapt it to a small microcontroller with little kilobytes of RAM, or you can put everything together and use many memory and many functions on your product. It has inspiration from Linux and Unix. It supports virtual file system, memory technology device, proc file system, nutshell, and many other things that resemble the Unix and Linux. There are some list of some microcontroller and microprocessor supported by NuttX. For example, almost all ARM are supported. The AVR from HTML and now microchip. MIPS, the LM32 is a FPGA, is a software core, microprocessor, microcontroller. The RISC-V is the new open source processor. The Z86, the extensor using the ESP32, the Z80s using the 80s personal computer, for example, and many others, but these are on small listing that's important to talk. Some companies using NuttX, Sony, Samsung, Motorola, Halcyon, 3D Robotics, Daruma, Verja Aero, and many other companies are using it currently. Okay. The main features, it's POSIX compliant, as Mr. Greg told. It's fully printable. It has virtual file system, as I explained in the previous slide. It has support to loadable kernel modules similar to Linux. It supports SMP, symmetric multiprocessing, so you can use it with dual core, 40 core, and many cores. It has real-time scheduling, FIFO, round robin, sporadic. It supports the ticklets operator support. So if you want low power consumption and you don't want to waste time scheduling your application without doing anything, the ticklets is better, and you have more how to say, it will more predictable. I don't know if the right word, but you can run fast without spending time doing nothing, for example, like when you use the normal scheduler. It supports the pseudo terminals, the PTI. It supports the I/O redirection, so you can, like Linux, you can redirect output from a file to other device and so on. It supports 3 memory modes. The flat mode, it's used when you don't have the NPU or MMU. You don't have any memory protection. So your application can access any part of the kernel. You can call kernel function directly. It's not a good practice to do it. It's not, you need to respect the kernel and the user land isolation. But if you want, you can do it. But please don't do it, because if you are doing, you are calling the kernel directly, you are doing something wrong. We have the protect mode when you have MPU. In the protect mode, many areas in the kernel, in the user space, are separated. So the kernel runs in a memory space and your application runs in other space. So your application will not cannot access the kernel directly. If you try to do it, you create a hard fault. Okay, and you have the kernel mode when you have the microprocessor instead of microcontroller. So you have the virtual memory, and each application can run separately.
Yes.
Maybe you need to use the mic.
Can you talk loudly?
Okay, I can hear.
I know that the ARM Cortex processor, the microcontrollers, do support the MPU, but is this a common thing on other microcontroller architectures as well, or is this an ARM-only thing, memory protection unit?
I don't know many about other microcontrollers, but I think other microcontrollers also support MPUs.
Yes, they do.
Yeah.
And at one company, at Verifone, we built our own NPU external. It's common.
Yeah. Oh, you're welcome. It also supports the high performance zero latency interrupts. I think it was created by the PX4 guys to, with Greg help, to avoid latency for processing some tasks. For example, if you are doing motor control, you can create a timer with a task like an ISR, interrupt service, that will do something when the timer is triggered your code, and it will not how to say, it will not interfere in the NuttX, but it's like the NuttX is not able to communicate directly. You have some tricks to get the thing's communication with the RTOS to get it working. But it's an option when you have very high speed controls to do. I think about few microseconds, maybe 5 microseconds. I used it in the NXP LPC 43 to get it working to control some CNC motors. So it was important to use it, because otherwise we have many latency to control the motors, and you cannot work with smoothly in the control if you need very high speed operations to control. It has native debug log, so you can use printfs, kind of printfs, separating by info, warning, and error, similar to Android log E, log I, log W. It's very similar idea. It supports power management, so you can use on device with battery and sleep almost part of the time. And also it has a native log system called syslog, similar to Linux syslog. About the file system, it supports all the FATs. It supports network file system. The BinFS, when you mount the binaries in a file system, you can run this binary directly. It supports the smart file system when you have SPI North, SPI Flash North, and it has where leveling support, so it avoids damage your flash. It supports the home file system when you have read-only file system to use. It supports proc file system similar to proc file system from Linux and other Unix. And also Greg created some time ago the Union FS. If I recall correctly, it was when you are trying to use the CGI to integrate two or more file systems.
So it allows you to overlay two file systems.
Yeah.
So that they look like one file. They look like one file system.
Yeah. You
So
glue
actually-
it together.
So actually, the BinFS, for example, lets you have just code in your binary blob that appears in a file system as executable files. And so the UnionFS works really nice with that because you can then take ROM code that's tasks that are in ROM, and overlay them with tasks that are maybe coming off of an SD card. And they all, like /bin, could be a Union file system of things on an SD card and things in Flash. It's actually pretty cool.
Yeah, yeah. Very nice.
You know, the CGI, it doesn't make any difference whether it's built-in code or...
Yeah.
Sorry. Question?
No.
You said SmartFS has the wear leveling
Yeah.
included, so if you're reading and writing to an SD card a lot for logs.
SD card is a little bit different because SD card, when they have some low-level control, I don't. Normally, for SD card, the wear leveling, I think doesn't work
So
this way.
if you had a NAND flash, then you would use SmartFS to.
NOR flash and NAND. I never used it in NAND, but because it was originally developed for NOR flash. But in NAND, I think it's possible to get it working in NAND as well.
It will require some work if you want to get it running with NAND flash, because NAND flash have additional problems.
Yeah, it comes with problem from factory.
Yeah.
The NAND flash come with bad blocks. So
Yes, and some other stuff. And SD cards have wear leveling of their own, so you don't do wear leveling at the NuttX level for the SD cards. Okay.
yeah, and the temp file system is similar to Linux tempfs, where you have the memory using like a file system, similar to run disk idea, but it's more dynamic. For network, NuttX support multiple network interface, so you can have, for example, Ethernet 0, Ethernet 1, ETH 0, ETH 1, and so on. It supports network routing to routing, for example, from Ethernet to Wi-Fi, and for any other interface. For example, if you are using the GSM cell phone, you can route it to Ethernet or to Wi-Fi. It supports IPv6, IPv4, IPv6, TCP, UDP, ICMP. Also Unix socket, domain name resolution, Wi-Fi with full MAC. It also supports the 6LoWPAN, and this use the same physical interface used to to ZigBee and other protocol. It also supports sleep, so if you doesn't have Wi-Fi in your board, you don't have internet, you can still have internet communication using the serial with sleep protocol. And also it supports, as I told, it supports the GSM modems, 2G and 3G, using the PPP. So it also supports the graphics. We have frame buffer support similar to Linux. It supports LCD, parallel and serial. For example, OLEDs and I2C and SPI. It has an NX graphics server with the idea is similar to Linux X server, but really small. It also has many graphic libraries, for example, fonts, line, curves, rectangles, per line, and so on. It also has the widgets, so you can create buttons, combo box, and so on. It also supports foreign graphics, like the little LVGL. I think we'll have a presentation about it. And also it has the VNC server support. So if your board does have an LCD, but it has Wi-Fi or Ethernet, you can see the screen over the Ethernet. For audio, it has the audio tone generator. This audio tone generator came from the PX4. It was implemented in C++ in high level, and I ported it back to create a native NuttX driver. And also it supports some real audios codec for playing music, play waves, and so on. This first one, the VS1053, is a SPI audio codec, and then also other from Wolfson, and it was resented by I forget the name of this company that bought the
Wolfson.
The Cirrus Logic. Yeah, Cirrus Logic by the Wolfson recently, but I think this device is still available in the market. And also it has the audio player where you can play local music and also play files from the internet. For the USB host, we have the CDC ACM modem class. For example, when you plug USB serial adapter in your board, if your board has USB host support, it will automatically detect and create the /dev/TTI ACM0. It supports mass storage, so if you have, sorry, this name is only existing in Portuguese, I think, is a USB flash drive or thumb drive, okay? It also supports keyboard, mouse, joystick, and USB hub. For USB devices, it means you can get your board and make it behave like, for example, the CDC ACM, it will behave like a serial device. For example, it is used to, for instance, it is used to have the serial console over the USB. It also works like a USB mass storage. For example, in your board, you have SD card, and you plug your board in the computer and make your board appear in your computer like a USB flash drive. So you can copy files directly to the SD card because it will show to your computer system like a USB flash drive. And also it supports the Ethernet over USB. There is the RMDs protocol, and also recently they have the ECM. I can't remember the name. I think ECM.
CDC, ECM.
Yeah, ECM is the ECM normally was used in Mac OS because Mac OS didn't have RMDs driver some time ago, and the only option was the ECM, and NuttX also supports the ECM. It also supports the composite device, so if you have the mass storage and the serial console working at the same time, you need to use the composite device support.
So I haven't.
It also supports the prolific PL2303 serial USB serial emulation. These are some microcontrollers with better support. Basically, all the ST Micro STM32 are really well supported. The HML microchip Sun 3, Sun 4, Sun V7, Sun D5, and others are also well supported. The NXP LPC 17, the LPC 43, and currently Dave and David Sidran and other guys, Ivan and many others in the list are working on it. Finish the support. Okay, comparing Linux with NuttX. Linux is for high-end processor with MMU and for 32 bits. It requires many megabytes of RAM and flash. Its support is started for PC and was adapted to embedded system. There is no support. There is no initial support to real time. They create a separate project, and it consumes much memory. Much power. NuttX, on the other hand, works in low, mid, and high-end microcontroller and microprocessor. It doesn't require the MMU or NPU to work. It works in 8, 16, 32 bits. It requires low memory, 8 kilobytes of RAM and 16 of flash is enough. And it starts for 8 bits MCU. It's real time from scratch and low power consumption. Why to use NuttX for IoT? It's compatible with Linux. It has a broad range of features. It is POSIX compliant, so you can create your application on Linux and test it on Linux and then move to NuttX. It is easy to move from high-end in the future, so you can start with low-end microcontroller and then you evolve to a bigger and bigger high-end processor. And it's very easy to move from one MCU to other since the MCU has a good support. Some example of Linux application ported to NuttX: the FreeModBus, the BACnet, the libc++, the SQLite, and many other libraries were ported from Linux to NuttX. So this is my contact. I think many of you already know my YouTube channel, and we can have contact over the list. Okay? Thank you guys.